Let's simplify some code. We'll go over this problem, 1 of 5, constructing a binary tree from preorder and inorder traversal. So, given two arrays with preorder and inorder, our goal is to create a tree node. So from this example, we can see that um, whenever, so in preorder, root comes first, then left, then right. In order, left comes first, then root and right. So we can say that from preorder, given all these values are the root nodes, and we can create the root nodes. And from in order, we can figure out if the left side and right side. So if you take a look on this one, when 3, and then we can take a look in order, and in order, whatever comes on the left side, it's in the left subtree. Whatever comes on the right side, is on the right subtree. So with this, we can actually start coding it. So what we need is that, like I was saying, like preorder will be used to create root nodes. Inorder will be used to create to connect left and right. So I'll be using so this is going to be depth first search style, and we'll be using recursions for this. So to code it, I will create a helper method, and for now, like I will just define them, and then we'll just apply all the required parameters in a second. So this is my helper method, and in here what I need is that for preorder, we are going one by one in order of this array, and creating root nodes. So for that one, I need to find a way to track it. So this indexes in order. So for I'll be creating an array with one value to just opening up a one box, and then it's like in there's like to trying to track the indexes in a recursion call. And for in order, when we find this one, we need to look it up in order, and to see left and right side and connect them. So for that one, for lookup, I'll be using hash map, because lookup is all of 1. And this hash map will be with in order's values along with its indexes. So we'll go until the length and save it to our imap. So in order I, and then giving the index of it. So for this 2, we'll be passing it to our index, and this one will be also in our helper method, and we need to pass our preorder, because like in a recursion helper method, we need to find the given value and create a tree node. Along with this, we need to track the left index with right index. We can take any of this array since the length is the same. So left side and right side. And our need to define the base case. So when left is bigger than right, then we will return null. Now, oh, this is now you need to create a tree node from pre-order list. So let's get a value from pre-order, and we have our array to track the indexes and then actually increment it for next recursion calls. So now we have our p value, which is 3 from here. Now we need to create a tree node out of this. So we will be giving our p value to here. Now we have a tree node with value 3. And we need to connect the left side with the right side. So for that, we need to use Inorder to try to figure out the left and right side and connect them. So we need to access the map and get an index of it, and then our p-value. So this is our Inorder's index. So in this case, we access to here, and then this is 0 and then 1. So we need to connect them now. Left with call our DFS again, pass all this required or required parameters, and so we can see that when we're connecting left side, we need to connect up until the given value I order. So we're here, we found it, and then it's like left side. To connect to the left side, we need to bring all this right to here, and then we'll be connecting it. So what I mean is that, so staying this way, and then since we know the indexes of this, we are bringing the right side. So we're bringing right side to here, we're connecting it. For right side, again, same required values, and then all those parts right here, we're bringing left to here. So because like we don't really, when we're here, it's like we don't need to, because like we're connecting right side, so we're concentrated on this right side of it. So that's why we're just like excluding the left side and up until the right. And we'll just return the root. So let's run it. Oops. Let's submit it. Perfect. So the time complexity for this problem is O of n, where n is all values in given arrays, and then space complexity is O of n, where n is all values in given map.